Okay, so let's talk about how to prove this fact. So the one side of the equation, the left side of the equation, is something we can just write down. We have explicit formulas for it. So let's do that. So we're trying to show. We're trying to. Whoops, let me get that out of the way. We're trying to prove that the magnitude of CV is equal to the absolute value of C times the magnitude of V. So I'm going to take this left-hand side and just start calculating it. So on the one hand, well, let me just write down what this vector V is. The vector V has coordinates, V1 through Vn. Right? And yeah, maybe n is 2, maybe n is 3, maybe n is 17, whatever. It doesn't really matter. So we'll just write that like that. Now, I have a formula for how to scalar multiply C times this vector, and that is it's CV1, etc., and then through CVN. In other words, you just multiply component-wise. Right? Okay. Now, I also have a formula for how to compute the magnitude of a vector with a bunch of components. And that formula is I take the square root of the sum of the squares of those coordinates. Right, so all I've done is computed the left-hand side so far, right? And I'm still kind of in process. Now you'll notice that there's when you multiply these all out, there's a c squared that's inside of each one of these factors. So let me rewrite this as square root of c squared times square root of v1 squared plus etc. through vn squared. And you'll recognize two things. First of all, this right here is that's the magnitude of v. Yeah, exactly. So let's write that down. That's that. This is the little tricky curve that a lot of students forget about. A lot of students are under the mistaken impression that the square root of c squared is equal to c, and it's not. This symbol here, this means greater than or equal to 0. It means the positive square root, right? So in other words, if you write that, if you want to talk about the negative one, you've got to actually put the minus sign in there. And if you're not sure which one you want and you want to refer to both of them, you got to put the little plus or minus. But that symbol means positive, or non-negative, excuse me. So, for example, note that the square root of negative 5 squared, well, see, negative 5 squared is 25. The square root of 25 is 5. Which is, in fact, the absolute value of negative 5. So I claim that this always works. The square root, let me just write it here, the square root of something squared is always the absolute value of that number. And that's where our result comes from, like so.
Okay. And do you have to show the left side, the right-hand side?
Well, but see, that we just got the right-hand side. So what So I started with the left-hand side. I computed it by known processes, and I concluded that indeed it is equal to that right-hand side.
Okay. I guess what I was getting really confused with proofs, because I was trying the others from last night with the the other properties for vectors.
Yeah.
But like I guess when I did the left-hand side, like I was trying to like do for the right-hand side, I got confused. I'm like, okay, am I doing too much? Am I right?
I understand.
could probably show you what I did, but like,
Yeah.
would you?
Hang on a second.